So good afternoon everybody, myself Acharya Vishvendra. Let's discuss today a JEE advanced based question on elasticity. So let's begin with the question. So here is the question that there is a block of mass M. It is being hinged by two wires of steel and copper. Young's modulus area and areas are given over here. Now we need to find AC. The first thing is this one, and it is being given that this is the midpoint of this particular thing, triangle. So let's begin. So we can say that in this diagram 1 upon AC is equal to sine 30, which is 1 by 2. So AC is going to be 2 meter from here. In the second question we can say that 1 upon CB is equal to sine 60, which is root 3 by 2, which gives us CB as 2 by root 3. Now if we assume that tension in this one is T1 and this wire is T2, so we can say that forces will be like that. So if we see that forces on this particular block, it is like T1 here, T2 here. So taking the components, we have these as the vertical components, these as the horizontal components. Making the condition of horizontal equilibrium that net force in horizontal direction is 0, which gives us T1 sine 30 is T2 sine 60. So the relation between T1 and T2 is this. Next, applying condition of equilibrium in vertical direction, net force on this is 0. So net upward force is equal to the downward force. So after the calculations, we get T1 as root 3 by 2 into mg. Fourth question is T2, which is T1 by root 3, which is mg by 2. Next over here is stress in 1. So it is force by area, so T1 by A1. So this will be the force, stress, sorry. Next is stress in wire 2. So stress in 2 is force by area, force is T2 by A. So after substituting we get this. Next is strain at 1. Strain is stress upon Young's modulus. So this will be the strain in first wire. Again similarly we can find strain in second wire. Then we can get elongation in the first wire as delta L1 is equal to this. Then in second wire as this. Then we need to find elastic potential energy density in first wire. So we know that elastic potential energy is half into stress into strain. Substituting the values, we get this as the elastic potential energy density in wire 1. Similarly for wire 2, we have energy density is half into stress into strain. After substituting the values, we get this as the energy density in the second wire. So in this way you have seen that questions in JEE Advanced are basically based on a number of integrated simple questions, and if you are comfortable with each question you can complete that. Thank you and have a nice day.